due l'asinello. E qui monitoriamo le cose. Io poi non lo so usare sto computer, quindi... E entra con... riclicca su Chrome. Se lo sai che io sono bravo. Sì, non niente. Entra con questo. Adesso su YouTube. Almeno c'è rispondi con l'account di questo istituzionale. Se vuoi entrare con tu, se no entri in incognito, se vuoi rispondere come Giorgio così, se no poi rispondere come sembra che stavo discente. Poi mi stanno a venire? No, sono. Il microfono l'abbiamo attaccato. Il microfono ce l'hai. Parla, ti sentono, già stanno a sentire tutto, quindi perfetto. Blasfemio. Sì. È partita. Quindi questo lo posso minimizzare tutto. Sì, minimizza questo e quanto vuoi. So, welcome everybody, whoever is watching. Welcome to this exercise session of robot programming. On the stage we have Luca, which is the tutor of the course and the one that will correct every single exercise that you will be doing. No.
Sorry guys, I'm using the Grisetti laptop and it's very hard.
At the end of this simple exercise that we will resolve in hopefully not long, with all the explanations that are required, we will also establish a Zoom session for the students at home and, of course, those that are in the class will have their time to ask questions about the course. Fai attentissimo. Ma perché?
Perché mi serve tutto. Volevo cominciare.
No. Vai sul sito Grisetti, pitching e lo vedi da là.
Perché non te lo vedere?
Sì. Che ci arriva. E mo da lì. Questo è quello che vedo fare.
Okay guys,
quelli loro non vedono.
can you all see the screen? Everyone can see the screen? No? Now? Better? Okay. Okay, so I like to start from the README. I hope everyone has an internet connection. I hope everyone has a laptop and everyone has a, let's say, power cable. The exercise should be very simple. We will write our first Cmake list. And I don't know if you already write it before, if you listen to the lesson of Professor Grisetti on Monday. And the first thing that we have to do, if it's not already installed in your laptop, in your system, we have to install the compiler and all the build essential, okay? So if you follow the README, okay, I think it's pretty easy. There are like 4 or 5 commands. And let me know when you finish this procedure. The README is on the repo that you have, and exercise, yes, folder exercise RP01 compilers and build system. Once you install the build essential, make sure that the GCC version, looks like this. depending on the version of Ubuntu that you have, if it's 18 or 20. Have you installed the build essential? Say yes, no? Okay. Now we install Eigen, which is a linear algebra template library. We will explain Eigen later on in the course. For the sake of this lesson, you just need to install this package. And then make sure to use pkg config in order to see if the package has been installed correctly, as explained by Professor on Monday.
Has any one of you downloaded the VirtualBox image for Ubuntu, or do you all have native install? You downloaded that one. And do you know the password? Because there's a colleague of yours which is asking the password and the username. Ah, all right. Okay, so you all have an own version. Devo guardare la pagina del corso dove era.
Has Eigen 3 been installed correctly? Everyone can see if the package is installed? Okay, great. Quella che c'hai nella home directory di robot programming è quella pubblica che vedono loro?
Quella pubblica che vedono loro non l'ho pullata.
Quella pubblica che vedono loro non l'hai pullata? Ok. Vabbè, potremmo fare pure da...
Fai da master.
Okay, guys, so as already said, we will write our first Cmake list to build this package, which is called minicore. Okay, this package, the structure of the package can be seen. I want to clarify this. Let's see if I manage to install it. Password. From next lesson, I will use my laptop, so I'm sorry about this.
Yeah, I'm sorry too, because it's a horrible thing.
So maybe this clarify a little bit the structure. I hope you can all see from behind. C'è un terminal da lezione?
No, fine.
Zoom in. Okay, maybe a little bit better. Okay, so we have to focus first on this Cmake list, on the first one. And then we will go inside the source Cmake list and inside the executable Cmake list. The first thing that I want to do is complete with you the first Cmake list. Okay, so if you use like an IDE of your choice, a text editor, whatever you want, you can open the project.
I would also say something about it, having a look at the folder structure.
Yes.
And then organizing the libraries and so on.
You want to do it?
No.
Okay. No, in verità no, perché ce n'è solo una di risorse. Okay, so the first thing that I like to explain is first, okay, we have only one external dependency that we use in this package, and this is Eigen, the one that you installed previously. This needs to be the header, because it's an header-only library, needs to be defined by the compiler, and we do this by using the find path command. Okay. Now here, did you pull the last version? Are you sure?
Alt tab, git pull. Okay, maybe you pushed this morning.
Okay, no, yesterday. Okay, and I wrote this for you. Okay, every external packages that you require usually provide a Cmake file that tells you how to include this project, this package inside your project. Okay, inside your package. And in Eigen, this is the stuff. They have this weird thing, signature of Eigen 3 matrix library. Okay, which is required in order to identify directories containing Eigen3, and then what you have to do basically is following the to-do. Okay, so when you see a to-do, then you have to write some code in there, and now we have a few lines to write. I added this if statement. Another thing that I like to say before you start the exercise is that you always need, at least for me, you always need a way of debugging, especially now this is an easy building, but when you deal with more complicated and very large building, then even for Cmake lists, even for Cmake languages, then you need there a way of debugging and printing out probably messages in console, like you do when you, I don't know, you write code in Python, in Java, or in C++, whatever. And as I wrote in the README, you have the message command that you can use in order to print in console whatever you like, and especially that's very important for the variable stuff. Okay. And the same thing is for if statement. You can use if statement, okay? So in this case, I added this if statement that if you don't find Eigen3, then the compiler will kick you out, and the compilation won't be finished, okay? So the first thing that we can do actually in order to see if you have installed correctly Eigen3 is creating a build folder and type cmake ... inside the build folder, so we see if all kind of inclusions are correct. Okay. So we create our build directory, we go inside build, and then we type cmake dot dot. Okay, so if you have an output like this one, okay, then that means that basically this step went well. I like to show what kind of error we have if we don't find actually eigen. Okay. I don't know how to comment on this machine. Retarded way of commenting, sorry. Okay, so here you can see, like, I removed the find path of eigen, and you can see what kind of errors you have. Okay, and this is the message that I wrote, basically. The message that I wrote, inserting eigen3 include here, which basically is empty. And here there was a dollar missing because we want to get the value actually of this. Okay, so if you manage actually to install everything correctly, this is not your case, and you can actually proceed with the exercise. So I suggest you to refer to the slides, okay, of Professor Grisetti of Monday, and try to complete this to-do, okay? The first one is actually to invoke the routine to find the package called eigen, actually, that you require the package. And then you want to specify additional locations of header files, okay? Our header files and our CPP files are inside the source folder, src. And I think you have enough information for now to start the exercise. Don't worry, we will give you the solution little by little in a minute, okay? So just give you some time to think, to read maybe. Cavo HDMI.
Tu hai staccato un cavo HDMI dal modo, no?
No, io l'ho solo attaccato. If you have any questions, any doubts, feel free to ask, okay? If I say some kind of unclear things, yes? I'm saying that in yours. Okay.
If you need help, you can also come at distance 1 meter. Distance 1 meter.
So guys, I assume that you followed the last lesson of Dependency, and I didn't ask you before this. This is very important. Our course is just a plus or no plus, okay? So it will be easy in the sense that would be like a 6 credit exam. The thing is that every lesson and every exercise follows the previous one.
They can't hear you if you stay there.
Sorry. You're right. So every lesson and every exercise follows the previous one. Okay. So if you jump something, then make sure that you go back and you at least read and try to understand overall what we did in the previous lesson. Okay. Otherwise you won't be able to, like, you will quit the course. Yes. Maybe. And this part of Git was written in the previous lesson on Monday. Okay, so this is not a problem now, but everyone needs to be aware on how the course is structured. Okay. For the guys online, don't worry if you don't manage to complete the exercise. We will give the solution in a second. The only important thing is that you have a look at the slides of Monday and you try to understand at least what you have to do in a, let's say, not complicated way. Okay, guys, so let's give the solution for the first to-do. Okay? Don't worry if you didn't manage to do this. Every package, every external package that you actually you want to include into your package you have to read the README online and you have to document yourself, because like most of the time it's different package to package. From the name to the Cmake file that they have and they provide. Okay, so the first thing that we have to do here, like we explained in the lesson of Monday, is to find the package. The package is called eigen3, and this is case sensitive. Okay, and this is a required external package that we have to include in our build.
Then will you blast the 2 lines on the top?
Which one?
The check variable is.
Yes, I could read it. Yes.
Yes, I mean, this would give me an immense pleasure.
Okay, I insert this just to let you know that you have if statement that you can use. Are horrible, yes, but in a way, when you are like building your system the first time, or maybe you have huge building, they may be helpful to debug.
Yeah,
and
making it longer, like
I don't want to delete it.
Yeah, exactly. Well, it gives me pain. Remove.
Okay, we remove these.
Remove. Remove. On top, can you remove also the line on top?
The line what?
Find path, because if it's a find package, find path shouldn't be necessary, right?
No.
Comment it.
Exactly.
Because find package doesn't find the path. Okay, like I wanted also to blast the line on the top. I wanted also to blast this part, because it really disturbs me. I mean, actually, like when you write a program, you write a function that does all what it needs to do. You don't write a little bit here, a little bit there, not like you want to go to a restaurant, but you have to go to another place to order the first course, and to another place again to order the second course. This is how you not do the things, right? And then the problem is that the find package, probably this macro, because this is in the end a small Cmake script invoked somewhere, presumably is not well made in the default installation. And it doesn't valorize the eigen3 include here.
Exactly. Well,
accordingly, in order that you can ask find package to find the package. What you will have is that the system will valorize some variables, but not the include directory, because they didn't do the package correctly. Is that clear? And then you have to do it by hand, and you do it by hand this way.
Yes.
Right?
We usually find in huge kind of packages are Cmake files, okay? So Cmake extension that you find actually in a folder of this package with all external dependencies. And every Cmake file, for instance, the Cmake file of eigen, will contain like this line of code. Okay, the Cmake file of OpenCB will contain like will specify where you have to find the package basically, and write where you have to find the package inside this variable which is called eigen3 include dir.
I mean, a solution to this would be to find where this Cmake file, where actually like I'm not on the blackboard, where you can highlight where this Cmake file is located, right? I mean, you can try to do locate eigen3.cmake. Shift Ctrl T. Locate is a Unix command. I mean, we will encounter a lot of Unix commands in our game, and I have just received the information that some of you are not skilled with this system. So as long as we will encounter commands in the shell, I will tell you what they do. Locate basically looks for every file that has a certain name. So locate eigen3. It looks in some sort of database which is attached to the file system, and it's updated regularly, all the names that match the pattern that you give. So if you say locate eigen3 or find eigen3, actually, in this case, it will tell you all the matches in the database. It's like a search, but it's a quick search done on a database, which is updated normally at night by all Unix systems to speed up the searches in the file tree. You could alternatively use the command find, but find does a physical search on the disks. Disk takes a lot of time. Okay? Luca issued the command locate eigen3. Can you go
yes.
back? Locate eigen3. No. Alt-tab. Alt-tab. Locate eigen3. Write the command locate. And you have to make the window higher because they don't see anything in this height. Those in the classroom. Okay. This is the command. Locate find eigen3 because by construction the find Cmakes have a beginning with find. No? And then there is the name of the package, and then there's the destination Cmake. So that's when you do find package eigen3, what will happen is that somewhere the system will look for these files, and if it finds find eigen3, it will invoke this file over here. Okay? By doing locate, we find, this is a command shell, we find all the million instances of eigen3, which I presumably have, and I suspect that eigen3, the eigen3 that I find is in ROS, one of those.
Yes.
So I have many. How Cmake chooses the first one that it encounters in the path, right? If we open this file with all the path, you find like all the commands that are in fact executed when you do find eigen3, which will in the end do some horrible things to look for the path, but we will not write find packages. We will just use find packages.
Yes.
Is that clear? But if there is something which goes wrong, and one has certain manuality, can go there and fix it. I mean, a reasonable choice now to avoid that abortion that we have seen, that we have to look for the include file by hand, would be to enter in the system and to change this file to valorize the path correctly. Is that clear? By copying the 2 lines that Luca had to write on top. This way, the find eigen file would have done everything by hand. Wow. Quit. Control D. Non ce l'hai? È gedit.
Sì, anche control.
Okay, you have a million editors in Linux. You have, you can choose normally with apt, which is the command that installs packages. Sudo apt install, and then the package name. You just pull a package, right? He opened, used a very simplistic editor, which is gedit. Okay. Now he had just written find return me the list of all possible matches for find Cmake, and these are actually files on the disk, right? And then you can open it with an editor. If you want to use gedit, you say gedit, and then you pass the argument. This is just okay. If you want to use Emacs.
What is the path? How can you choose the path between?
Okay, there is a bit of entropy in Giorgio's laptop. Okay, so these are all, let's say, packages that are basically his stuff. Okay, don't worry, you will have much less entropy in your system, and maybe you will find only the find eigen3 that comes with the eigen3 that you installed before. Now in this machine we have installed ROS. Okay, so the find eigen3.cmake will be in the ROS directory.
Okay. I mean, you find on my laptop, you find many instances of eigen3, because since the find eigen3 of the default Ubuntu installation was sick, each time I was pulling out some program from someone, they had imported, they had redefined their own find Cmake, find eigen3, right? That's why you have all this mess. This means that there's a set of packages which is called srg2old, where I wrote a new find Cmake, just to avoid the 2 horrible lines that I never want to see there.
The one that he asked me to delete, okay?
Exactly.
Find path eigen3 include here, which is basically this one, okay?
Obnoxiously sick, right?
Long story short.
Let's see how many questions we have.
Okay, we can move on, and we can write using the include directories commands the two variables that we need that will tell us where our inclusion is actually. Okay, and we are talking about eigen and our sources. Okay, our sources are inside minicore src. Okay. Okay, we know this variable is the one that we populated above on a find path. Okay, and with the if statement of before that Professor Grisetti asked me to delete, we understood that this variable was populated and not empty. Okay.
And why do we have to do this? We have to do this because we will be using the eigen3 library, right? And in our program, which was specified, and in our program then we have to say, hey, look for the include files into the directory which is called eigen3 include dir, okay? And then also, given that we are lazy, inside the structure of our project, we have all source files which are in a folder which is called /src, right? Source. So that we make a little bit of order. You open a project, you might have readme and all other things, and then you have a source directory where you put the source. You might have a data directory where you put some data and whatever, right? So it's a good practice to put the source directory, the source, in a folder which is called src or whatever inside your main project thing, right? And so, in order to avoid every time to do source / into the include file, we might just say include all files by definition, which are in this directory here, which is project source dir, so now, /source. So that we basically omit the prefix source from all includes that we will add. Is that clear?
This variable is set automatically by our cmake command that we run on the terminal after this, and this is what we said before, okay, in the line that we wrote previously. Now, I would suggest you to try to build your system, even though we have we build our system partially, but at least we see that we don't encounter any errors, okay? And the first time that you build is good practice to do it step by step, and not like just at the end.
Yeah, you do a small function, you compile it. You do a small thing, you compile it, you verify it. You don't write the full program.
Then when you're skilled, you write the full program, you compile, and nothing works.
Okay, now Luca used two commands on Unix, because I have also to say that. He used the ls command, which is the equivalent of the DOS command dir, and he used the command rm, which is equivalent to the DOS command erase or delete, I don't know which one it is, which deletes a file that you give it as standard. Here you use the command rm -rf. -rf is the option. -r means recursively, f means don't ask me. So it's a very dangerous command. So delete recursively and brutally everything you find everywhere in this folder. Star is a wildcard that expands to every file, every file that I have here. If you do it in your home directory, you won't be happy.
If you are interested, just to open and close a very fast parenthesis, if you are interested about any commands and you don't know very well how to use them, then what you can do, because we installed the man command before, we can look for man rm, for instance, and this will tell us how it works and what are the options. Okay, so this is a very useful thing if you don't want on Google and start to typing Stack Overflow, whatever. And I mean, once you are skilled with this command, then is very powerful, and all you need is in your terminal, basically. Okay. Okay, so having said this, we will write cmake again, okay, in our build directory, and we will make sure that we don't encounter any error. And in this case, we didn't encounter any error, okay? And this is good. This means that what we have done till now, which was the inclusion of our header, of our external package, eigen3, and our project header, are okay and have been found by our compiler. What we have to do now, since we are working with nested Cmake list, and working with nested Cmake list is nice because you can fragment the structure and you can avoid to write millions of lines of code in only one file, okay? Like programming in object-oriented parallel. Oh, sorry. Yeah.
Ma sono messa panna da loro.
Infatti stavo a morire. Okay. What I was saying is, since we are working with nested Cmake list, we have now to include other subdirectories that we want to include actually in our build. Now, the src directory has already been included by me. Okay? As you can see, other than the build directory that we just created, that contains our build information, we have another directory that needs to be included in our build system. Okay? So you can do this. This is very simple. Analogous to src, but with the other directory that we have. Okay?
And you might notice that there is a good practice to put the build, to have a folder which you call build, where basically the source will be built. So where all the intermediate files, the .o and whatever will be generated, in order not to clobber your source space. Normally, in your repository, in your Git, you will say, Git, please monitor the source directory, monitor the executable directory, but you will never do git add build. Because otherwise you will be committing intermediate files which are automatically generated, which is completely useless because it just saves space and doesn't give you anything. Okay? So you create a folder where you put all the byproducts of the compilation. Okay?
If you have any questions, whatever comes inside your mind, then you feel free to ask. Don't be shy. If you don't want to ask to me, you can go on the YouTube channel and ask Giorgio.
What was? I can do only one thing.
What do you want to do?
I don't know. You said something about it.
No, sorry. I was joking. Okay, so this is our last instruction that we will give to our main Cmake list, okay, which is to add subdirectory and the other folder which is called executable. Okay, now how nested Cmake list works. What you are doing now is basically telling your compiler that you have two folders that will contain another Cmake list. Okay, so if you don't put a Cmake list.txt inside the executable folder or inside the source folder, which is src, then your compiler will blast you and will say, oh, there is no Cmake list here, I cannot do anything, I will exit the compilation. Okay, and feel free to do this because this is a good way of understanding where the errors come when you encounter actually real errors. Okay. Now, once we have done, since we have finished the first Cmake list, we can build again. Okay. So always do a clean. So remove all the stuff inside your build folder.
Maybe we have to explain slowly what we do when we invoke Cmake. You might observe the path here, which is, if you can highlight for those at home, which is that we are in into the folder build inside the folder mining core, right? Which is
The package.
The package.
Yes.
All right. So it's the build is a folder that he created, or I don't know, he committed. It's already there. Like he made it for you, or did I push out or not? Both?
No, not push out.
Okay. He created the folder build. Now from the folder build, if you type Cmake, Cmake will say, hey, where is a Cmake file here? I don't find it, right? Because it just created the folder build, it's empty now. So you have to tell Cmake, hey, dear Cmake, look for your top level make Cmake file, dot is a command that the wildcard that actually the symbol that means the one directory up. So if we go from build with dot, we go one directory up. This means execute. This tells Cmake start from here in looking for your Cmake lists, and then Cmake will start compiling everything. Not compiling, reading the Cmake file, doing all the sort of things. We might observe that it starts to do interesting bits that you never thought. It starts to identify the system. It says, oh, this is the compiler, this is the version of the compiler. I'm finding the commands, the shell commands with which invoking the compiler. This is the full path to the executable. It does all sorts of things, which I will not explain because I'm not in operating systems now, but it looks for the C++ compiler. Why does it look for these things? Because from the source files and their endings, it realized that this file is a C file. If you would just like put in a Go file or something like that, it will realize, oh, then I have to look for a Go compiler. Okay? It configures the environment, and then at the very end, it says, okay, I produced a make file, and build files have been written. This is the generation phase. It produced some make files that you don't have to do by